Our first topic will be under hardware. So all your instructions and data will go through these three processes, which is your input, processing, and your output. So inside your CPU, there's three components. One is your control unit, one is your arithmetic logic unit, ALU, and your registers. This control unit controls the flow of data and instructions and tells the ALU what operation to perform. Your ALU is the fundamental component of the CPU. It performs arithmetic and logical operations such as your plus, minus, multiplication, division, compare, and, or, and not. Your registers are just memory cells in the CPU. It is the rapid access of instructions and data by ALU and your control unit. Larger amounts of data is stored temporarily in the RAM, your main memory. So let's go to your RAM. So your RAM stores instructions, data, and results. It stores information in bits, 1 or 0 only, which are organized into bytes. So 1 byte equals 8 bits. Your RAM holds data in cells with addresses. So below shows the table of your memory size conversion. The disadvantages of your RAM. It is volatile. Volatile means that if your computer is turned off, it will not store the data anymore. And it needs to be constantly refreshed to retain its data. So a constant power supply is needed. Secondly, it's also quite expensive. There are also many types of RAM outside, so you are suggest to take a look. Your read-only memory, your ROM. Your ROM is used to store small amounts of data permanently, which is not volatile. Usually, it cannot be written too easily, so it can only be read from. It stores information like boot up instructions. Secondary storage. Your secondary storage is your permanent storage of data. It is cheap, and it has large capacities like your hard drive, your thumb drive, your CDs and DVDs, and your magnetic tape. Flash memory is basically your thumb drive, so it is non-volatile. It can be reprogrammed. It's used in SD cards, smartphone, internal storage, USB drives, and solid-state drives. Your input and output devices. So, example of your input devices are your mice, your keyboards, touchscreens, microphones and cameras, your scanners. So your output device are something like your monitors, speakers, and printers. So the interaction between your CPU, RAM, and your secondary memory. So during the start, the program and data will be transferred to RAM. One instruction and data is fetched from the RAM to the CPU at any one time. The ALU computes, stores intermediate results in registers. Final results are then transferred back to the RAM. So these final results are either shown on screen or saved to hard disk, which is used later. Now we're talking about software. So system software consists of three things. One is your operating systems, your utility programs, your software development tools. Basically, the operating system manages your computer hardware and software resources, and it provides common services for computer programs. For your utility programs, it analyzes, configures, optimizes, or maintains a computer. For example, they are like your task manager, your command prompt, your disk management. Your software development tools are used to create, debug, and maintain your software. The examples include Microsoft Visual Studios, your code blocks, or your Xcode. So, operating system. Operating system is loaded when your computer is started or booted. It manages your CPU, your memory, and hard disk usage by other softwares. So this simplifies the operation of a computer for the user, and it controls the access to the computer. Your application software allows the user to perform tasks unrelated to the computer, such as your web browsers, which include Microsoft Edge, Google Chrome, Mozilla Firefox. Your office suites, such as your Microsoft Office, Apple iWork, or your Google Docs. These also include your computer-aided design, CAD, such as your AutoCAD, SolidWorks, Inventor, etc. Your programming. Programming provides instructions to the computer to carry out tasks. This is all written in a programming language that could be understood by the computer. Your programming is divided into two types of language. One is low level and high level. So your low level is actually a machine code, which is your assembly language. And your high level language are, for example, your C, C++, your Java, and so. So machine code is the only language understood by a CPU. It differs for each type of processor. It's rarely used by programmers now. So, example, the function to calculate the n Fibonacci number on your Intel X6 CPU is as shown. So yeah, it's actually really difficult to use because you don't understand what it actually is. Your high-level language uses English words. This can be used for multiple types of processors. Your high-level languages will be compiled actually, into machine code, which is much easier to understand. Language standard. Each high-level language has a set of rules called syntax. Your syntax defines the symbols and your structures used in a language, like grammar. And you must follow it strictly. Any deviation from the syntax will result in syntax errors. Your programming processes. Number 1, problem solving. First, you need to know about your program specs, your program analysis, and your ergonomic design, your solution procedures. Next, you need to implement. Implement includes your coding, testing, and your maintenance of your program. Your algorithm. Your algorithm must be precisely stated. It's the finite sequence of executable steps for solving a problem. It's usually written using informal language, English-like statements known as your pseudocode. So this is an example of your pseudocode. Let's say you want to find a larger number between number 1 and number 2. So this is how usually programmers write their algorithm, like to test whether it is accurate or not, before writing the actual program. So your input will be your number 1, number 2. So if number 1 is larger than number 2, then you set the maximum into number 1. Else, you set the maximum equals number 2. After every if, you have to write an end if. So your output will be the max. Your edit, compile, and link cycle. First, you create a program in an editor after analyzing your pseudocode. Then, you have to translate the statements into machine language using a compiler. This is done by your computer. An object file is then created by the compiler. So this compiler will actually link the object file with another components or libraries using a linker. If you have any syntax error, your compiler will identify you during the second step, which is translating your statements into machine language. Then, you have to fix it again, go back to your program, and find out the errors. Some compilers will tell you where the errors are to help you in changing your program. Your file produced will be, for example, like your name.c. Name stands for your file name. It can be any file name. Your file name.obj object file, and your name.exe, your executable file. So everything will be done in an IDE, which is your integrated development environment. An IDE will contain the editor, compiler, linker, and debugger, which will find the errors. You can use, for example, your Microsoft Visual C++, your code blocks, or CHIDE. So errors in programs. Bugs are corrected in a process known as debugging. There are several types of bugs. For example, your syntax errors, which are your grammatical errors, like not using your correct syntax, missing symbols. For example, let's say your comma becomes a full stop. Yeah. So the program cannot be compiled because there's an error when it's converting it to a machine language. There are also logical errors, which is your wrong algorithm or formula use, such as your multiply is used instead of addition. So the program produces incorrect results when you run it out, of course. Then your runtime errors. Your runtime errors are actually the errors that occurs when your program is executed, such as when you input a value that cannot be processed, like 0/0, or infinite error, or infinite values. The program will crash when it enters a runtime error. An IDE can only inform you about syntax errors.